In this video, we will learn about this law of indices. Let's look at this expression, 5 to the power 4 divided by 5 to the power of 6. Based on the law of indices, it is equal to 5 to the power of 4 minus 6, which can be simplified to 5 to the power of negative 2. On the other hand, we can simplify 5 to the power of 4 divided by 5 to the power of 6 by dividing each pair of 5 by its common factor to get 1. Notice that the numerator will only be left with 1 and the denominator is left with 5 times 5. Hence, 5 to the power of 4 divided by 5 to the power of 6 is equal to 1 over 5 square. Therefore, 5 to the power of negative 2 is equal to 1 over 5 square. Now, let's look at this example. 4 squared divided by 4 to the power of 5. Based on the law of indices, it is equal to 4 to the power of 2 minus 5, which can be simplified to 4 to the power of negative 3. Similarly, we can simplify 4 squared divided by 4 to the power of 5 by dividing each pair of 4 by its common factor to get 1. Again, the numerator will only be left with 1 and the denominator is left with 4 times 4 times 4. Hence, 4 squared divided by 4 to the power of 5 is equal to 1 over 4 cubed. Therefore, 4 to the power of negative 3 is equal to 1 over 4 cubed. Next, let's look at another example. 7 squared divided by 7 cubed. Based on the law of indices, it is equal to 7 to the power of 2 minus 3, which can be simplified to 7 to the power of negative 1. Similarly, we can simplify 7 squared divided by 7 cubed by dividing each pair of 7 by its common factor to get 1. Now, the numerator is left with 1 and the denominator is left with 7. Hence, 7 squared divided by 7 cubed is equal to 1 over 7. Therefore, we can say that 7 to the power of negative 1 is equal to 1 over 7. Now, what if the base is a letter of the alphabet? Just like this example where the base is the letter A. Based on the law of indices, it is equal to a to the power of 3 minus 6, which can be simplified to a to the power of negative 3. Similarly, we can simplify a cubed divided by a to the power of 6 by dividing each pair of a by its common factor to get 1. Again, the numerator is left with 1 and the denominator is left with a times a times a. Hence, a cubed divided by a to the power of 6 is equal to 1 over a cubed. Therefore, we can conclude that a to the power of negative 3 is equal to 1 over a cubed. Take a look at these examples again. Do you see any pattern? Notice that 1 over 7 here can be written as 1 over 7 to the power of 1. See how we can express a negative index as a positive index. Now try to express a to the power of negative 3 in positive indices. Yes, it is 1 over a cubed. Given the base a and the index negative n, the negative here actually represents a reciprocal or an inverse. For example, the reciprocal of a is 1 over a. We take the reciprocal of a to the power of negative n by writing down 1 as the numerator and bringing down the base and the index without the negative sign as the denominator. Hence, a to the power of negative n can be written as 1 over a to the power of n. 1 over a is the fractional form, So a to the power of negative 1 is equal to 1 over a. In general, when the index is negative, we can write the index form in fractional form.